Okay, this is Intermediate Algebra, Chapter 8 Review, Part 2. So, what we're going to do next is finding the midpoint. So, suppose I have the point -5, 3, and 6, -9. So, to find the midpoint, I have to find, well, first off, the x-coordinate of the midpoint and the y-coordinate of the midpoint. So, the way I do that, I take each of these x-coordinates here, and I add them, -5 plus 6, or 6 minus 5, and then I divide it by 2. Well, -5 plus 6 is 1, and then divided by 2 is just a half. Now, I'm going to do the same thing for y. Look at the y coordinates, right? We have 3 and -9. 3 minus 9, or -9 plus 3, divided all by 2. 3 minus 9 is -6, divided by 2 is -3. So the coordinates of my midpoint, I'll call capital M, is 1/2 -3. Next, we're going to talk about solving a compound inequality, which is when you have two or more inequalities you have to solve. So for instance, if I have x plus 1 less than or equal to 3 and x plus 1 is greater than or equal to -1. Well, I have to solve each inequality individually. So first I have to solve this right here. Subtract 1 from both sides. X is less than or equal to 2. And so -1 from here. X is greater than or equal to -2. So if I were to graph this on a number line, -2 going this way, right, because it's greater than or equal to. And notice I darken them in because the equals is there. I have to include that. Less than or equal. Well, since it's and, that means they're inclusive. So that means you have to include both, which means these two are bounded by each other. So in actuality, it just becomes this. -2 less than or equal to x less than or equal to 2. Or in interval notation, I can just say x is on bracket, because the equals I included, -2, comma 2. And since there's equals here, I put another bracket. So that solves that one. Then, now we're going to look at another one where it's 5x minus 1 is less than 3, or 1 minus x is less than -1. So again, just like the last one, I solve each inequality individually. So first, I'm going to add 1 to both sides here. I get 5x less than 4. Divide by 5 to both sides. X is less than 4/5. For this side, well, I gotta get rid of that 1. Subtract 1 from both sides. -x less than -2. Now I divide by -1 to both sides. So x, and since I'm dividing by a negative, I flip the sign, because negative, when you apply a negative to something, anytime you're multiplying divided by a negative, it changes the sign, becomes opposite. So here, the opposite of less than is just greater than, and -2 divided by -1 is 2. So if I were to graph this on a number line, I have 4/5 going that way, and have 2 going this way, then notice how I have an open circle. Why? Because there's no equal sign under these. So that's why I have it drawn this way, like this, with an open circle. Now, since it's an or statement, they're not inclusive. So that means whatever values I choose to plug in, say if I pick an x value less than 4/5 or an x value greater than 2, it only has to satisfy one of them, and that's it. So then, really, this is just x less than 4/5 or x greater than 2. So the way I could write that in interval notation is, x is on -infinity to 4/5, or 2 to infinity. So now we're going to talk about if I have an inequality where now it has more than two sides. So suppose it's -3, x less than x plus 2 less than 5. Well, to solve this, you have to balance it just like the other equation. So for instance, I want to get rid of 2 here, right? Well, I subtract 2, not just from these two sides, but also this side. So -3 minus 2 is -5 less than x less than 3. That's the solution to that. Or in interval notation, x is on -5. Notice that in parentheses because there's no equals here, so it's not included. 3. And again, parentheses there because the 3 is not included. There's no equal sign. So now, what if I have something a little more complicated, such as let's see, -8 less than 2 minus 1/3 x less than 3. Well, I want to get rid of the 2 here first. Subtract 2 from all the sides. So this gives me -10 less than -1/3 x less than 1. Now I need to get rid of that -1/3. So I can multiply by the reciprocal. Well, the reciprocal of -1/3 is -3. I distribute that to all three sides. -3 times -10 is 30. Now, since I'm multiplying by a negative, I have to flip the sign. So it's greater than x greater than -3. Well, this doesn't really make sense. 30 greater than x greater than -3. So the way I can write that is -3 less than x less than 30. Or in interval notation, x is on -3 to 30. And again, I have parentheses because there's no equal sign there. Now we're going to talk about absolute value equations. So suppose I have 3x plus 7 is equal to 10. Well, that gives me two equations because absolute value, remember, absolute value of a number always makes it positive unless it's 0, it stays 0. So I'd have 3x plus 7 equals 10 and 3x plus 7 equals -10. So I subtract 7 from both sides. 3x equals 3. Divide by 3, x equals 1. This side, well, I gotta get rid of that 7. 3x equals -17 divided by 3. X equals -17 over 3. Or you can just say -5 2/3 because -17/3 as a mixed number is -5 2/3. So that's the solution for this. And the last problem we're going to cover is an absolute value inequality. So suppose I have 3x minus 2 is less than or equal to 4. Well, that's going to give me 3x minus 2 less than or equal to 4. And 3x minus 2 with a -4. Now, the reason why I didn't draw the sign here is because since it's negative here, you have to change this. So the opposite of less than or equal to is greater than or equal to. So it's very important to remember that. So now you want to solve both of them separately. So I have 3x, I had 2 to both sides, 3x is less than or equal to 6. Divide by 3, x is less than or equal to 2. Here, I'm just going to add 2 to both sides. 3x is greater than or equal to -2. Divided by 3. x is greater than or equal to negative 2/3. So this is where you want to be careful, because since it's an absolute value inequality, you have to be careful to make sure you don't miss any solutions. So if I draw, a number line, and okay, I have negative 2/3 greater than or equal to, so a dot goes like that, 2 less than or equal to. Well, if I pick negative 2/3 here, and I plug it in for x, that's negative 2 minus 2 is negative 4. Absolute value negative 4 is 4. Well, 4 equals 4, so we're good. If I plug in 2, the other endpoint, that gives me 3 times 2 is 6, minus 2 is 4. Absolute value is 4 is just 4, and that equals 4. If I pick a value between negative 2/3 and 2, such as 0, well, 0 minus 2 is negative 2. Absolute value negative 2 is 2. So that works. But now, let's say we pick a value beyond 2. Well, 3. 3 times 3 is 9, minus 2 is 7. Absolute value of 7 is 7. That's not less than 4, so that's no good. Now I want to pick a number less than negative 2/3, so negative 1 I can pick. And if I plug in negative 1 for x, that gives me negative 3 minus 2, which is negative 5. Absolute value negative 5 is 5, which is not less than 4. So therefore, it would be, the solution would be negative 2 is less than or equal to x, less than or equal to 2. Or in interval notation, x is on bracket, because I have the equals here, negative 2/3, comma, 2, and since it's equals here again, I put a bracket. And that is the solution to this absolute value inequality, and that wraps it up for Intermediate Algebra Chapter 8 review. I hope this video helped. Best of luck to you all, and I'll see you next time. Bye-bye.